So digital image fundamentals is the second part or second unit in the first module where we have to talk about image and acquisition. We had already known, right, that image sensing and acquisition where energy is converted to electrical signal, digitizer this electric signal is converted to digital image. Same concept is being carried on here, but so here let us start. So it is a critical process in DIP as it determines how images are captured and converted into digital form for further analysis. See why it is converted to digital format for further analysis itself, okay, and manipulation. It outlines the principle of sensing and the fundamental concepts involved in generating digital images. See, I just skipped the unnecessary parts. You can simply fill over here whatever you want also, but first let us write the quality, then we can fill with quantity. Illumination and scene interaction is nothing but first illumination where the light comes. So the process begins with illumination source that emits energy which interacts with the scene being imaged. So I'll tell you what is scene is nothing but on which the light falls or energy falls or absorbed or reflected. Okay, this energy can come in. So it's saying for what are the sources of energy for this visible light commonly used in everyday programming. Infrared and X-ray light nothing but it is used in medical imaging industrial applications. Ultrasound is also used in medical diagnosis, also in some industrial applications. Then computer generated pattern. So remember this CGP. It is useful as you have to mention in scene elements. Synthetic imaging. So what is scene imaging does? Nothing but it consists of familiar objects or complex objects like the biological tissues or your or even computer generated images. So this is nothing but a scene which on which the sources are falling. So you leave the rays, see infrared rays you leave on biological tissues, right? And you leave ultrasound on the geological form, and you leave this CGP on these images, right? So that's what it is. So nothing but the interaction between and the energy source will result in energy which is reflected or transmitted in which is captured by the sensor. So sensor have captured this what is the energy now. That's it. Now we'll go for the second part of this process. Image sensing model is nothing but the transforming the energy which is sensed by the sensor into digital image. It can be through various sensor arrangements. So there are three types here: using a single element, using a sensor strip, and using a sensor array. Okay, so here a single sensor is there, nothing but photodiode. Just describing. So here generates a voltage to the light intensity. So here what it does, it generates an voltage, a current proportional to the light intensity. So how much intensity is current will be there, and so it creates 2D images. The sensor must move relatively with the sensor like linear direction. It's not like four direction, only one left or right direction or front and back. Only one direction is there. Mechanical scanning is nothing but the method involves a mechanical setup where a film negative is mounted on a drum and the sensor moves to capture. I'll just explain you this here. So these are the images. So you can see here. Simply drum is nothing but this whole rod rotation. So film is there here. Mechanical rod is there mounted on this drum. Here sensor is mounted. It moves left and right, and what is captures the. In this type, 2D arrays are used. This consists of multiple sensing elements arranged in a grid. So there is a grid in which all things are allowing for simultaneous capture of entire image without the need of mechanical movement. See, mechanical movement is not required. Automatically, it captures all the image required. The sensor captures all the images. Example is CCET, common type of sensor used in images. They have thousands of sensing elements and allow for high quality image. So here, image formation is nothing but the incoming energy is focused into sensor array. So whatever the illumination is there is fall on a sensor array of sensor, which generates the output proportional to the light device. This might be an important question, as this diagram is also important here. Sensor array is a scene like that; it just fall like that and just creates. I'll just explain here. Then okay, that's it. See. Focus on the which generates an output proportional to the light received. Proportional to always remember whatever the it depends on the light received on the sensor. These outputs are then digitized to create digital image. Same, see, these all are the electrical signals, right? Now, then this will be converted to digital image. Sample image formation model. So, see, under the one topic itself, under this image sensing acquisition, all these topics had come. Now, we will talk about this third topic, that is image formation model. So here then image acquisition by sensor strip, same thing but differences in inline sensor strip is there. So this consists of multiple sensors arranged in a line. So on a line, only one or two sensors were there on that mechanical grid on that mounted box is what's there. Two sensors there, if you can see here. But here, what happens? There is a mechanical strip. So here, nothing but the circle itself is nothing but this whole strip. It is, if you rotate and make it a circle, becomes this thing. So here, this is one mechanical strip on which whole sensor strip is pasted, and all the sensors are in each linear motion. So this is linear motion. Whatever you have to object, not this is a 3D only, which you have to sense, scan, will be sent and what is the linear motion itself. So obviously you have seen this in some movies where they send the whole person in some circle type of thing, where and all will be there. So that's nothing but for cross-sectional view for your body. See, so captures one line at a time. The motion is perpendicular. The strip allows for the command. Nothing but see. This is the circle. Right? This is perpendicular. So here see, sensor strip is like this. Motion is like perpendicular like that. So it's nothing but one tunnel is there. Now here you are moving like this. Sorry. So you are moving just like this, just passing from a tunnel like that. Application communication flatbed scanners, airborne image systems, where the sensor strips captures the data as the aircraft moves area of interest, or ring configuration. Two are there. One is flatbed and one is ring. So flatbed in the sense like a bed, it will be there. If planes move, it just captures. The ring is nothing but medical imaging, like CT scans. So tables are there, circle. We just go and results of CT are obtained. And using sensor, this is the third. In the beginning of this lecture on this subject, I have told you what is DIP. It has coordinates. This x and y are the special coordinates, and y is the amplitude. So see here, it can be represented as two-dimensional, where the value of each coordinate responds to the intensity of the light or gray level. See, so now illumination and reflection. The image intensity is determined by two components. So first, illumination are there, and reflection is nothing but the amount of light incident on the scene, in the sense how much light is falling on the scene. Reflectance is nothing but reflected from the object or in the scene. Okay, illuminance is I of x y, r is reflectance is r of x y. So in such a way that f of x y is equals to this into this. Okay, here this as c dot is nothing but it is a code for the computer to generate the multiplication symbol. So just that is nothing but just a dot. Okay, remember this into this. This equation indicates the image intensity is the product of illumination and reflectance value. So see, product is that is the multiplication, that image function. So for further understanding, you can simply see here. So here this value is less than equals to 0 and less than so from 0 to 100. Same ways illumination also range from 0 to infinity. Sorry, here 0 to infinity, 0 to infinity, whereas reflection ranges from 0 to 1. Okay, that's it. And you can simply see the intensity. Let the intensity gray level of the monochrome image at x comma b not L is equals to f of x comma y. So just saying ranging the, so this can be represented L between from L minimum to L max, where this L minimum can be equals to I minimum into R minimum, or max can be equals to I max into R max. Usually which ranges from C. If the example is 0 comma 1 or 0 comma C, like that, we can simply use this for understanding. Just mention it so that innovator understands. Then conclusion and the key points are here. All these things you can just see as a key points, whatever is required. Scene element, sensing element, sensor strip, sensor array, illumination source. That's, we'll move on to the next topic.